of an interesting lesson, but will not make nearly as exciting of a video. So making predictions and investigating results. Today you will investigate what happens when you make changes to a Mobius strip, and I'll tell you, it's kind of a fun lesson to do in class. Mobius strips are kind of neat. You might actually want to Google a Mobius strip video and just see some of the cool things that you can actually do with the Mobius strip. Long story short, it ends up being a shape that doesn't actually have sides, or it has one side. It's kind of weird. Anyways, so as you investigate, you will record your predictions on your results in a table. You will then analyze the data and use your results to brainstorm further questions and investigations. As you analyze your data, you may start to consider other related questions that can help you understand a pattern and learn more about what is happening. This way of thinking, called investigating, includes both generating questions and rethinking predictions when the results are not what you expected. So what happens really is we just have an investigation, we make a prediction what might happen, and then we just go with the result. And again, it has us use this Mobius strip, and some kind of cool unexpected things happen when you go through these different experiments. So like I said, I really would encourage you to watch a video on Mobius strips. However, the main point of this lesson is not the Mobius strip. The main point of this lesson is the investigative process. The investigative process is a way to study and learn new mathematical ideas. Mathematicians have used this process for many years to make sense of new concepts. In general, this process begins with a question that helps you frame what you want to investigate. For example, a question such as, if the Mobius strip is cut has two half twists, what will happen when that strip is cut in half down the middle? Can begin an investigation to find out what happens when the Mobius strip is slightly altered. So again, we start with the question. Once a question is asked, you make a prediction or a conjecture based on the information that you have so far. A conjecture is a mathematical statement based on incomplete evidence that has not yet been proven. And then you explore and you see kind of what happens there. You have your question, you make a conjecture, and then you try and explore that conjecture and see if it's true or not. So next, the exploration process begins. This part of the process may last a while as you gather enough information to make a conclusion or change your conjecture. For example, you may make a conjecture about the angles in a polygon based on a few examples, but as you draw and measure more polygons on graph paper, you may discover that your conjecture is incorrect. When this happens, investigate some more until you have new conjecture to test. When a conjecture seems to be true, the final step is to prove it, that it's always true and not just true in that one example. And one example I'll say would be like 2. 2 plus 2 is 4. 2 times 2 is 4. So you could say, hey, look, anytime you add the same number together, it's the same as multiplying the same number. But you didn't prove that, because if you use in another example like 3 plus 3 is 6, and 3 times 3 is 9, clearly that falls apart. So like I said, just because it works in one instance doesn't mean it's always true, and then we would set about trying to prove that. So that's really the goal of lesson 121 and introducing you to the investigative process.